In section 1.7, we're looking at solving absolute value inequalities. So this is going to combine the notes from 1.7a with the notes from 1.6, and we're looking at a different kind of solving here. An absolute value inequality has an absolute value and an inequality. If the absolute value of x has to be less than or equal to 2, that means that the solutions have to be within 2 from 0. So that means that the solutions could be, let's see, 1 is less than 2 away from 0. 1.5 is less than or equal to 2 away from 0. 2 is less than or equal to 2 away from 0. But so is 1/2 and 3/4, and 0 is less than or equal to 2 away from 0. And then it mirrors over here. So all of these numbers up until -2 are less than 2 away from 0. Less than or equal to 2 away from 0 means that all of the numbers in here are the answers to the questions. So 2 is an answer, and -2 is an answer. And then the answer to the question for the numbers that are less than or equal to 2 away from 0 are all of the numbers that are in between. And so this is an and inequality that we practiced from the other page. The answer to this question are all of the numbers that are within 2 away from 0. In this example here, we're looking for all of the numbers that are greater than or equal to 2 away from 0. So that would be numbers like 3 and 4 and 5 and 6 and all of the numbers that are bigger than 2 over here. And then the numbers that are -3 and -4 and -5 and -6 and all of the numbers that are less than or equal to -2 over here. So the numbers that are 2 and then all the numbers bigger than 2 fit that inequality, and then the same over here, -2 and all of the numbers that are less than or equal to -2 fit that inequality. And so this is an OR compound inequality. The numbers that are greater than or equal to 2 away from 0 are the numbers that are less than -2 or the numbers that are greater than or equal to +2. And so depending on the direction of the inequality symbol, you might have AND problems or you might have OR problems. When we solve these, we need to do the same split that we remember from solving absolute value equations. The inside is the same direction and the same sign as the original inequality, or the inside is the opposite flip of the inequality and the negative of the number. We'll solve these separately. X is greater than or equal to 2, or x is less than or equal to -10. And then we want to graph these on a number line and see what they look like. X is greater than or equal to +2, or x is less than or equal to -10. And so we still have to write the answer to this question, and we can write that in the space underneath. X is greater than or equal to 2, or x is less than or equal to -10. And so this is an OR problem. The graph tells us the direction of the inequality symbols and how to write the answer to the question. Let's see. The inside is the same direction as the inequality symbol and the same value of the number. And then the inside is the opposite direction of the inequality symbol and the negative of the number. And then we'll solve both of these. 2x is greater than 8. So x is greater than 4. And then x is less than 3. And so on this one, when you graph it, x is greater than 4 goes this way, or x is less than 3 goes this way. And so when we write our answer to the question, x is greater than 4 or x is less than +3, we get the answer to the question here. What do the two solutions to the inequalities above have in common with each other? They both are OR inequalities. We can tell that from the direction of the graph when we graph it, but we can also tell it, if you look back at the very beginning, both of these started out as greater than or equal to or greater than symbols, and so that's also going to be something that tells us that it's this type of problem. On paper, example number 3 looks just like example number 2, but we'll see when we get down here to write the answers that it's actually a little bit different. Let's see. So what's inside the bars, same direction of the inequality symbol, same value of the number, and then what's inside the bars, opposite direction of the inequality symbol, and then the negative of the number. And then we'll solve each of these separately. So x can be less than 4. And then when we solve this one, we'll get x is greater than or equal to -8. So this is what's different about this one. When we come down here to look at the answer to the question, x is less than 4 starts going this way, but then x is greater than -8 starts going this way. And so what happens is, you see how they're facing sort of both into the middle? That means that this, I'm not going to draw two arrows on it. It's going to be an and inequality. And when I write my answer for an and inequality, it gets written in this manner. So x is in between -8 and +4. And so we write our answer like this, like we would an and answer. On this one, let's see, what's inside the bars is less than or equal to, so that one's the same. And then what's inside the bars is greater than or equal to the negative of that number. So again, just like previously, we're going through and doing the two parts and solving them separately. 2x is less than or equal to 8. So x is less than or equal to 4. 2x is greater than or equal to -10. And x is greater than or equal to -5. So when I graph this one, x is less than or equal to 4. That one starts to come this way. But then x is greater than or equal to -5. Greater than starts to come this way. And so that's how I know that they go in the middle. And so when they're shaded in the middle, we have to write our answer like one of the compound and inequalities that we practiced previously. And so again, the graphing direction lets us know that it's going to be an and problem, but if you come back up here to the original questions, less than or equal to both result in an and answer. What do the two solutions above have in common? And both of them are compound and inequalities. And so what these two have in common with each other is that they both work out to be and answers to the problems. Down here in example 4, we're just looking at two different problems that kind of have some manipulations that you need to do. Feel free to use the back of the notes if you don't have enough space to fit these in like I have them spaced in here right now. Let's see, so on this one I'll have to add the 5 to both sides to start. And then I'll need to divide both sides by 2. Remember, you need to get the bars by themselves first. And then once you have the bars by themselves, that's when you split it off and make 2. So x minus 3 could be greater than 1, and then x minus 3 could be less than -1. Be careful over here, the direction of the inequality sign changes, and the +1 changes to a -1. So x is greater than 4, x is less than 2. X is greater than 4, x is less than 2. And so on this one, because of the direction of the shading, I know how to write my answer to the question. X is greater than 4, or x is less than 2. And this is an or problem. Notice that it started out with a greater than symbol, and so it finished with an or problem. Over here, I'll minus the 1 from both sides to start, and then to get rid of the 1/2 that's out front here, I'll times both sides by 2. So 3x plus 6 is less than or equal to 6. Now that I have the bars all by itself, I can split it off and make my two cases for solving. So 3x plus 6 is less than or equal to 6, and then 3x plus 6 is greater than or equal to -6. So again, the +6 changes to negative, but then the direction of the inequality sign also changes as well. And then I'll go through and solve both of these separately. Divide both sides by 3, so I'll get x is less than or equal to 0. And then over here, I'll get x is greater than or equal to -4. So if x has to be less than or equal to 0, but if x has to be greater than or equal to -4, they're both pointing inwards on each other, and that's how you know that you're supposed to connect them. Remember, when you write the answer to the question, the smaller number goes first, the x goes in the middle, and then the larger of the two numbers goes last. This is a compound and inequality. And if you look back up to the top where we started on example B, it had a less than or equal to sign, and that was your hint that it was going to be a greater than. The less than or equal to sign at the beginning was your hint that it was going to work out to be an and inequality. So the direction of this sign can help you decide which way it's supposed to go. And you can remember those two in that way if you want to.